Let's move on to chapter pressure 11 on page 114 and 145. We have been discussing about pressure exerted by solid and liquid. Its unit is Pascal. Pressure exerted in solid downwards. The solid exert pressure on the surface of another object or any substance. Due to the weight of the object, the pressure exerted on the particular area will be increased. You know that pressure depends upon two factors, that is area, the other one is force. Liquid also exert pressure. A liquid exert pressure in all the direction, downwards, upwards and sideways. We are going to discuss the pressure exerted by the liquid in sideways, upwards and in all direction by the help of activities. Activity 3 is to show that liquid exert pressure. Okay, the materials required are glass tube and also balloon water. Now you are going to take a balloon and tie the balloon at the one end of the open end of the test tube. Here both the ends of the test tubes are opened. So one end you tied the balloon, the other end, through the other end of this test tube you are going to pour water. Now what do you observe? The balloon which is tied at the lower end of the test tube will be bulged, will be swollen because of the pressure of the water. The water you poured over the balloon which exert pressure. Due to the pressure the balloon bulged. This shows that liquid exert pressure. Secondly, you are going to pour some more water. More water you have to pour over the test tube through the open end of the test tube. What will happen? The balloon seems to bulge more. In more extents it bulges. What is the reason? More the water, more the pressure. More the height of the water column, it exerts more the pressure. Due to this more pressure, the balloon will be bulged more. Now let's move on to activity 4, which is to show that pressure exerted by the liquid depend on its density. Density depend upon mass per unit volume. What is mass? You know, number of particles per unit area. You take water and mustard oil. You tell me which will be thicker, which will have more density. Definitely it is mustard oil. Whereas water has less density than mustard oil. Here in this activity you are going to take two same sized glass test tube and the rubber membrane, water, mustard oil. Instead of rubber membrane you can take two balloons also. Tie this membrane, that is two balloons, in two test tube. I told you these test tubes both the ends are opened. So at one end of the test tube you are going to tie the balloon. Like this two balloons you are going to tie in two different test tubes. Now you are going to pour equal quantity of water and mustard. And you are going to add water in the first test tube and mustard oil in the second test tube. Okay. So one end you tied a balloon, the other end you are going to pour water. What will happen? Which case balloons are of same size, test tube is of same size, water and this mustard oils are equal quantity. So tell me in which case balloon will be bulged more? Definitely second test tube B, in which mustard oil is kept, because density is more. Mustard oil's density is more comparing to water. That is the reason it exerts more pressure. Due to more pressure, the balloon will be bulged more. This proves that pressure exerted by the liquid depend upon density also. In the activity 3 shows that pressure exerted by the liquid depend upon the height of the liquid. If the height of the liquid is more, then the downward pressure exerted by the liquid will be more. So far we have learned two properties of the liquid pressure. The liquid pressure depends upon the height of the column, and also liquid pressure depends upon the density of the liquid. Here is an activity 5 to show upward pressure exerted by the liquid, downward pressure exerted by the liquid, and lateral pressure, that is sideways pressure. In this activity you require long cylindrical tin and water. Here in can 1 you are going to take a small hole at the base, and in can 2 you are going to make holes around the can at the same height. And in can 3, 3 holes you are going to take at equal size, one below the other. In can 1, you are going to close the hole temporarily with your finger and you are going to pour water into the can. Now you are going to remove the finger, then what will happen? Water flows out through the holes. This shows that water exerts pressure downwards. Can 1 hole is present at the bottom of the can. Now you are going to empty this can 1 and push it into the tub filled with water. Now you will see that water rushes into the can through the hole. This shows that water exerts downward pressure also. Now come to can number 2. In can 2, you have taken holes around the can at equal distance, at the same height. Now what you are going to do, you have to close all these holes temporarily with the help of tape. Now fill the can with water. You are going to pull out the tap. You are going to remove the tape which is pasted over the hole. The water will start flowing out of the side of the holes with the equal force. This shows that water exerts pressure sideways in all directions. Water exerts equal pressure in sideways. Water exerts equal pressure in all the directions. Now in can 3, there are 3 holes, one over the other at different levels with equal sized holes. Same way you are going to close these all 3 holes with the help of tape. After that you are going to fill this can 3 with water. Now you are going to remove this tape. We observe that water starts flowing through the holes, but water from the lower hole, that is lowest hole, flows with the greatest force. Whereas in second hole, water flows out with less force. Whereas in third hole, water flows out with least force, very, very less force. This shows that pressure in liquid increases with increase in depth or increase in height of the water column or liquid column. This activity shows that pressure exert downwards, liquid pressure exert upwards. Liquid exert equal pressure in all direction. Pressure in liquid increases with the increase in height of the liquid column.